Section 4.1, solving linear inequalities in one variable. So first thing, notice 3 is less than 7. That's a true statement, we all can agree on that. What about if we added something to both sides? For example, if we add 2 to both sides. Well, we'll still get 5 is less than 9. Still a true statement. What about if we subtract? So once again, we'll start with 3 is less than 7. Let's subtract this time. Let's subtract 9. And I'm just picking numbers here. 3 minus 9 is negative 6, and 7 minus 9 is negative 2. Notice we still have a true statement. So notice both of these are still true statements. So what that tells us is that we can add or subtract something from both sides, and it doesn't change the inequality. Just like we could add or subtract to both sides of an equation, and we were okay. So now we're going to do the same thing and look at multiplication with division. So 10 is greater than 8. We're all okay with that. What about if we multiply by a positive 4? Well, 10 times 4 is 40, and 8 times 4 is 32. We still have a true statement. So we still have a true statement. Alright, once again, starting with the true statement, 12 is greater than 3. This time we're going to multiply by a negative number, in this case negative 2, and we'll get negative 24 is greater than negative 6. Notice that's not true anymore, because negative 6 is greater than negative 24. So the key thing to keep in mind is when you're multiplying or dividing, and it matters if it's a positive, the inequality will stay the same. If it's a negative, you have to flip your inequality. Notice in this case, to make this a true statement, it would need to be like this. Notice the sign has flipped. So now we're going to solve our inequalities. We're also then going to graph our solution and write it in interval notation. So first we're going to solve these. And remember, it's just like solving equations, except if you multiply or divide by a negative, you have to flip your sign. Let's start with notice we only added and subtracted, so our sign doesn't flip. But now we are dividing by a negative, so our inequality is actually going to switch. So we have now solved it. We've got to write this on a graph. Remember, this is 1 and a 4. We want the numbers less than or equal to. So we have the equal, so we've got a bracket. And we want the numbers less than that, so we're going to the left. But then we also need interval notation. So that means we want all the numbers from negative infinity up to 5/4, but including 5/4. So we've got our bracket. Next one, we've got to distribute this negative 3. Subtract our 12. Divide by negative 6. So we'll get x is greater than 2. So on a number line, we want the numbers greater than negative 2, but notice not equal to, so we'll have our parenthesis. So we want all the numbers from 2 on up. So now we have a half. We can just multiply both sides by 2. Notice though this 2 was positive, so our sign is not going to change, even though this is a negative here. and we want the numbers greater than -8, so we'll be going this way. And it's not including, so it'll be our open parenthesis. So you have -8 to infinity. Now we're going to deal with compound inequalities. And something to keep in mind, and means we want both of these inequalities to be satisfied. So let's start by drawing our number line and putting the two numbers we know we're going to be dealing with. And one way to do this is to graph each of these separately. So let's start by graphing x is greater than -1, and I'm going to do these below, and you'll see why here in a moment. And then this other one, so now we've got our both of them drawn, but we want to know where we have both of them, because it's and. So where do we have both lines? From here to here. So that would be our answer for our graph. And then in interval notation, we want from -1 up to 3. This second one, we can do the same way, but notice we already know x has to be between 0 and 5. So we know we're going to be dealing with 0 and 5. And it's greater than or equal to 0, but also less than 5. So there we go. In interval notation, we're going from 0 to 5. Alright, same idea. Let's go ahead and draw our number line. We know we're going to have a 2 and a 4. So let's start by looking at this one. We want greater than or equal to 2. So we're going to go this way. And then this one we also want greater than 4. So my question is, where do we have both lines? The answer to that is we have both lines from 4 onward. Notice 4 is not included here, so that's why it's not included there, because we need where both of them have it. So then in interval notation, we're just going from 4 up to infinity. Same idea once again. So let's draw our number line. We know we're going to have -8 and -5. Let's just take it piece by piece. X is greater than -5. So that's going to be going to our right. We also have less than -8. And remember, we have an and, so this means where do we have both lines? Well, we don't have both lines anywhere. So this is going to be just no solution, because there's nowhere that satisfies both this inequality and the second inequality. So now we're going to look at or. And what or means is we can have 1 or 2 lines. So let's go ahead and get our number line going. We know we're going to have 0 and 3. When we graph x is greater than 3, so that's going to be going to the right. The second one to the left. So we want where we have 1 or 2 lines. So this is for or, we want 1 or 2 lines. So where it fits one or the other. So that means where we've got one or the other line is from here and going this way. So in interval notation, we'll have from -infinity up to 0, but we'll also have from 3 to infinity. And this just means union, which in our case it means or. That's how we're using it. So now let's look at this one. So we want x is greater than or equal to 2. Going this way. X is greater than 4. Going this way. So now, once again, where do we have 1 or 2 lines? Well, that would be all the way back from this 2 on up. So from 2 to infinity, because remember it's 1 or 2 lines, and there's 1 or 2 lines starting right here. Alright, let's look at this one. X is greater than -5. X is less than 3. So now where do we have 1 or 2 lines? Well, we have a line everywhere. There's always at least 1 line. So this is -infinity to infinity. Meaning any number you picked, no matter what, is going to work. So now we're going to solve this compound inequality, and then we're going to graph it and use interval notation. So the first thing, notice this means this middle thing has to be greater than 4, but we also have to have this whole thing less than 8, and we need it to fill both of those. So it's going to be an and, because it needs to be greater than 4 and less than 8. So now we just solve each of these individually. Don't forget we have and in the middle here. So now we want to know what our answer is going to be. So let's go ahead and graph these. We've got 3, we've got 4 1/3. Graphing this first one, we want x is greater than 3. And the second one, less than here. Remember, and is where we want both of our answers. So here's our answer. And in interval notation, this will be from 3 up to 4 1/3. Now this one, we'll do it the same way. We'll break it up. That middle part has to be greater than the left, and it also has to be less than that right side. And now we'll just solve each of these individually. Notice though we're multiplying by a negative, so our sign will flip. So I'll have -3/2 is greater than x. And then 1/2 plus 1/3. Multiply by 6/5. Now let's go ahead and graph these. Graphing this first one, we want where x is less than this. Graphing the second one, we want greater than 0. Remember, it's an and, so where do we have both of the lines? Well, we don't have both of the lines anywhere, so it's going to just be no solution. now, same idea, but we've got an OR statement. We'll just solve each of them individually. So we'll get x is greater than 0. And now this other side we're going to have to distribute, but that's okay. So we're going to be graphing both of these. X is greater than 0 or x is greater than or equal to 3/11. So let's go ahead and get our graph. First one, x is greater than 0, open to the right. Second one, greater than or equal to 3/11. Now remember, we want OR, which means where there's at least one line. So our end answer is from here on. And then in interval notation, it'll just be from 0 to infinity. Now we're just going to go from intervals to inequalities. So this is just kind of going backwards from what we've done. So if we have from -5 to infinity, that means if we were to graph this, we'd be going from -5 to the positive direction. This means we want the numbers that are greater than -5. Now this one, if we were to graph it, it would be from here to here, and the numbers in between. Which means that our x has to be greater or equal to 6, but also less than 7. So x has to be between 6 and 7. And now our last one, we graph this. This means that we're going from -infinity to 4, meaning we want everything below, and then also from 10 up. So that means we want x to be less than or equal to 4, or x has to be greater than 10. And remember, this should be your key that we're going to have an OR in our answer. And this concludes section 4.1.